The LaPlace domain allows us to convert derivatives in the time domain to algebraic expressions in the S domain. Here we are taking the LCCDE and converting it into the transfer function, which is equal to y of s over x of s, and can be simplified as shown.
The frequency response can be found from the transfer function by evaluating s at j omega every time there is an s in the transfer function.
Using the transfer function found in the first part, those zeros and poles can be found using the roots of the numerator for the zeros and the roots of the poles for the denominator.
Given an input x of t, we can convert this into the Laplace domain by taking the Laplace transform. Now, in order to get the y of t output, we will multiply h of s times x of s to get y of s. We substitute the values in that we solved for earlier, and we can see that the s squared plus 9 terms cancel, so we're left with s over s plus 1 squared. Now, we will perform a partial fraction decomposition in order to find the terms of the numerator. Now we can see that the bottom is going to have an s plus 1 squared term, so we're going to solve for it using the derivative method. And we can see here that the b term will have a negative 1 in the numerator, and taking the derivative to find the a term, we're going to find that that's just going to equal 1. So now using the values that we solved for, we're going to put those into the numerator. So now y of s is going to equal 1 over s plus 1 minus 1 over s plus 1 squared. And in order to get from the time domain, from the Laplace domain to the time domain, we will take the inverse Laplace, and we have the value shown.